Hello, welcome to another episode of Chem Sparks with Anita. And for this episode, we'll be solving this question on the board. The question says, write the electron configuration for each of the following species. The first one is magnesium atom. The second one is sodium ion. The third one is nitrogen ion, or you call it nitride, okay? It's called the nitride ion. Remember what we define electronic configuration to be. Electron or electronic configuration shows the distribution of electrons in the what? In the orbitals of atoms of elements, okay? Now coming to this species that we have on the board, this is the atomic number for each of these what? Elements, okay? 12 is the atomic number of magnesium, 11 is the atomic number of sodium, 7 is the atomic number of what? Nitrogen. Earlier, when I defined electronic configuration, I also explained that we write this electronic configuration using these what? Atomic numbers, okay? These atomic numbers, which is the number of protons, is also equal to the number of electrons, okay, in a neutral atom. Now, this is a neutral atom of magnesium. We are going to write the electronic configuration of this magnesium using this 12 without adding or removing anything. And how do we do that? To write this electronic configuration, what is expected of us to write here is the SPDF electronic configuration, not the shell electronic configuration. Okay, so let's proceed. To write this electronic configuration, we go as follows: 1s2, 2s2, 2p6, 3s2. So if we check the number of this superscripts here, this stands for the number of electrons. The s orbitals can only take the maximum of 2 electrons, and the p orbital can take maximum of 6 electrons, okay? If we add up this number of electrons, we'll find out that the sum is equal to what? 12. This is 2 plus 2, 4 plus 6, 10 plus this, 12. So this is the electron configuration for magnesium atom. Now let's write for sodium ion. Now for this sodium ion, remember, this plus here shows that sodium lost 1 electron, okay? And if this is the atomic number of sodium, that means the number of protons present in this sodium ion is still 11, but the number of electrons has reduced by 1 because it lost 1 electron. So the electronic configuration for this sodium ion will now be 1s2, 2s2, 2p6, okay? It lost 1 electron, and if it's losing 1 electron, we'll end up having 10 electrons, okay? So the electronic configuration will now be 1s2, 2s2, 2p6, giving us a total of 10 electrons, which is present in this what? Ion. Then let's write for nitrogen. This is the nitride ion. These 3 minus here shows that nitrogen gained what? 3 electrons to become the nitride ion, okay? So it gained 3 electrons. The 3 electrons added to this 7 here is going to give us a total number of what? 10 electrons. The number of protons present in this ion is 7, but the number of electrons increased by 3. So 7 plus 3 is going to give us 10. That means the nitride ion has a total number of what? 10 electrons. So the electronic configuration for this ion is 1s2, 2s2, and then 2p6. It has the same electron configuration with sodium. What name do we call ions that have the same electronic configuration? We call that isoelectronic ions. So that means sodium ion and nitride ion are isoelectronic. Do you have any questions? If you have any, you can drop that at the comment section. Okay, thank you for being part of this episode. See you in the next episode of Chem Sparks with Anita.